for the last chunk of covalent nomenclature, we're going to deal with acids and hydrates, which if you look very carefully have one thing in common: hydrogen. Hydrogen's kind of a pain, but it's very useful. With metals, hydrogen's going to act like an anion. It acts negatively. The metal takes on a positive, hydrogen takes on a negative. So you name it just like we named any ionic compound or ion, hydride ion. Hydrogen as an anion is hydride ion. This is review. Okay? When you put it with a non-metal, you now have it acting like a cation. The key there is it acts like a cation. Okay? It takes on a positive one-type charge. So let's look at a couple of these. HCl, H2S, H2O, if you were to look at them like ions, they're charge balanced. But the thing is, they're all covalent. But as soon as you make any of those hydrogen charge balanced compounds, where it's with a nonmetal, aqueous, so something like HCl, if you make it aqueous meaning you put it into water, as soon as you do that, it acts just like a cation. It splits into two separate ions, the hydrogen ion and the chloride ion, just like any other ionic compound, but it still started out as covalent. So HCl by itself, hydrogen chloride. HCl in water is hydrochloric acid. But for this course, we're not going to be too pesky about that AQ. You just roll with them. If you have hydrogen acting like a cation and the formula's charge balanced, you have an acid, the end. So these would be hydrochloric acid, hydrosulfuric acid, and hydrocyanic acid. You don't even have to tell me how many hydrogens because it's covered in the charge balancing aspect that hydrogen brings with it. When you name acids like this, if there is no oxygen, the prefix is hydro, the suffix is ic acid. Okay? But when you have oxygen, this changes a little bit. Without oxygen, hydro. With oxygen in my anion, I get rid of the hydro. That's the first thing that goes. I just roll with the ion that I started with. And if I have ite ion, it becomes aus acid. Ate ion becomes ic acid. So hypobromite ion, charged balanced with hydrogen, becomes hypobromous acid. The ite became aus, and I don't throw hydro on it because I'm more interested in the oxygen. Or without oxygen, hydro. With oxygen, no hydro. This is something you can review. The aus and the ic actually went with transition metals with multiple charges, so something you should check out. Now for hydrates, which also involve hydrogen but are very simple, this takes you back to counting and covalent, so that's something nice, something you can use twice. So one is mono, two is di, and so on. Hydrate just means water. We're going to use these prefixes to count water. So the MgSO4 part, that's review of ionic nomenclature. Right there you have magnesium sulfate. But the waters, well, 4 means tetra, and H2O we call it hydrate, so magnesium sulfate, tetrahydrate, or 4 waters. And we would write them with that dot. Another example, copper 1 or cuprous phosphate octahydrate. So there's my formula for the ionic version part of it. By metal, non-metal, we put them together like that. And octahydrate just means 8 waters. Done. Hydrates are actually very simple as long as you can name the ionic component of it. So the main thing is get down your general rules for acids because hydrates should take you no effort. And that concludes covalent nomenclature.